Welcome back to my channel, guys. Today we are looking at Codeforces Round 856, Problem C, Scoring Subsequences. So we are given a sequence, basically an array, and the score of the sequence is basically the product of all the elements in that sequence divided by the factorial of the length of the sequence. So S1 into S2 into S3 all the way up to SD by 1 into 2 into 3 into 4 all the way up to D. So this is the score, and there is also one more term called cost. So what is cost? Cost is the length of the maximum score. What do I mean by that? If for the maximum score using this formula, we took a subsequence of length 5, then the length 5 is the cost of the subsequence. Now, if the maximum cost can be received by two or more different lengths, then the maximum length would be taken as the cost. I'll explain all of this in a while. So we are given an array, and the array is basically non-decreasing, or in other words, it's kind of sorted in ascending order. And we have to find for each prefix array of this the cost of the sequence. Like prefix arrays are arrays starting from the first element and going up to the first, second, third, fourth, etc. So starting from the left end, all the subsequences are considered here. So those are basically prefix arrays. Now what are we given? We are given an integer n, and we are also given an integer array, and we have to print out a resultant array which basically outputs the cost of the subsequences till that element. Like for example, the array 1 2 3, the first prefix is the array 1 itself, the second prefix is the array 1 and 2, and the third prefix is the array 1 2 3. And for each of these prefixes we'll have to output the maximum score. So for the first prefix only 1, the maximum score is 1. For the prefix only 1 and 2, the maximum score is 1. And for the prefix, the entire array, the score is 2. How is it happening? I'll explain now. So let's take the example 1, 2 and 3. 1, 2 and 3. The first sequence is the number 1 itself, only this much. So what is the maximum score that can be achieved? 1 divided by 1. For the second prefix, there are two options, or rather three options. One, if we take this element, then it's 1 by 1, and then we take this as the next sequence, then it will be 2 by 2, because this is 2 factorial and this is S1 and this is S2. Similarly, we could have also taken this as the S1 and made 2 by 1, and then taken this 1 as the next element and taken 1 by 2. Why am I following this numerator by denominator format? Because the score is basically S1, S2, S3 dot 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 Sn by 1, 2, 3 dot 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 n, right? So if you notice, once we have the first element, we would only want to add the second element if the fraction S2 by 2 is greater than 1, or that is S2 greater than 2. Similarly, we would also only want to add the third element when S3 is greater than 3. And similarly, we would only want to add the fourth element when S4 is greater than 4. Only then they increase the score. Otherwise, because of these divisions, as we increase the length, the score might decrease if the numerator value is not sufficient. So let's look at the prefix 1, 2 and 3 for this example. For a sequence of length 1, we would obviously want to take the highest. So we would do 3 by 1. Then for the next, we could do 2 by 2. Now this is just 1, so it will not affect the score, but it will affect the cost. Why? Because if the score originally was 3, and after multiplying 2 by 2 also it's 3, but the cost earlier was 1, as in the length was only 1, and now the cost is 2. So for the maximum score 3, we want to maximize the cost 2, and we also want to output this cost, right? So that is why the output was 1, 1 and 2, because for the entire array 2 is the cost. For the first element, the only option is 1 by 1 equal to 1, and the length is 1. And for both of these elements combined, we would have to take 2 by 1, and then the next option would be 1 by 2, which we don't want because it only reduces the score. That's why again the length is 1. So for the second prefix, it's 1. So it's 1 comma 1 comma 2. So now we are done understanding the examples. So what is the logic and how do we solve this question? So we are given that the elements are in a non-decreasing order, that is A1 less than or equal to A2 less than or equal to A3 less than or equal to A4 and so on. So suppose in our comparisons we are comparing this segment of 3 elements. Logically speaking, to maximize the score, first we would go with one element which would be the highest of these. What is highest of A2, A3 and A4? Since it is an ascending, it's A4. So we'll take A4 and then divide it by 1. Now the next element is A3, but we would take A3 and divide it by 2. So we would like to take A3 only if A3 is greater than equal to 2, because even if it is equal, we want to maximize the cost. Similarly, we would want to take this A2 by 3. We would want to take this only if A2 is greater than equal to 3. Right. So this way, for any subsegment or prefix rather, we can go about calculating. Now, one more thing to notice here is that the denominators keep on increasing and the numerators keep on decreasing. So the moment we find a case where an element is not to be taken, let's say A2 is less than 3, then we will not take this, right? That also means that we will not take A1. Why? Because A1 is even smaller than A2 and A1 will be divided by 4. So there is no way this can be adding any meaningful value to the score. So what we are doing is we are finding the index till which we are counting as a part of our score, which in this case happens to be from here to here. This is the range, and from here onwards we are not counting. So this is the breakpoint. Our goal is to find this breakpoint, and the rightmost value will always be the maximum. So for a prefix that ranges from here to here, this will always be the R value and this will be the L value. And we are asked not the score but the cost. What is the cost? Cost is nothing but the length. And the length, the formula for the length would be R minus L plus 1, which is the length of any range. So we know R because we'll be looping from 0 to n minus 1, and the index itself is the R, right? Because that is the largest element. Our goal is to find the L for each index and just output this length. That's it. How do we find the L? So there are two ways you could go about it. One is a binary search approach because this is a sorted array. Right, so you could do a binary search to find the L. But if you notice very carefully, the L pointer, let's say for a particular iteration happens to be here. For the next iteration, it will either be here or go this side. Meaning it might consider this element for the next iteration as well, or it won't. Why am I saying this? Because for the current iteration, A2 is being divided by 3. But as soon as the R moves 1 this side, A2 will be divided by 4. and its chances of being counted in our score is only going to decrease. So there is no way this L pointer is coming here. The L pointer will only increase. So if you notice, the L pointer just makes one journey from here to here, and you can just maintain a L pointer, like say L is equal to 0, and keep on increasing it L plus plus until you find the optimum position. And then you could use this L pointer in your next iteration also to go rightwards for the amount of steps needed. And the R, as I said earlier, will always be the index. So let's look at the code. Here I've taken the array and I've set the L pointer to 0, and this is my second iteration where I'm actually doing the operations. And while ARR of L is less than the length, why am I saying less than the length? Because if you notice here that for the segment A2, A3 and A4, length is equal to 3, and the first element is divided by 1, second element is divided by 2, third element is divided by 3. To find the L, the element has to be greater than the length, right? This, we want to find this index. That's why we are checking while A2 here is basically ARR of I. If ARR of I is less than length, then we don't want it. We will do L plus plus and go rightwards until we find such a case. So that's what I've done here. ARR of L less than the length. Length is I minus L plus 1, L plus plus. And once we have found a L pointer which actually fits, what we'll do is print the length of that subsegment, which is the cost. So as you can see here, in this question, I'll look at my accepted submission. Yeah, this is the logic which I've implemented and it got accepted. Thank you guys for watching. See you in the next one.